Welcome to Answers Unleashed, a talk show to help you reshape your brain with science and faith so you find the answers in front of you. We have all been living in a pandemic. Everyone in the entire world has faced the COVID-19 coronavirus pandemic. At the beginning of the pandemic, everybody didn't know what to do and no one knew that the virus was spread through the air. It wasn't until months later that research scientists discovered that the COVID-19 virus was being transferred in the air. And it was up to science and scientists to find a way to keep it from spreading. Now, what was introduced during that time frame is a mask. I'm going to put on my mask here for you. You more than likely saw people walking around with a mask on. And the mask was supposed to help people. And at first people said, wear a cloth mask. And then when new variants came about, they said, wear an N95 mask. Now, they said, don't wear it on top of your mask, wear it underneath. And then as more Delta variants come about and even Lambda variants and other variants about, scientists know that the virus is propagating and spreading through the air. So they tell you to wear preferably an N95 mask. Now, what is the science behind this? Why does a mask work? And why does a cloth mask work? And why does an N95 mask work even better? Today, we're going to look at just the basic science of how masks work to protect people in pandemics and protect people in closed settings. All right. I want to give you a visual here. Let me put this down. Have you ever gone to the laundry? Have you ever gone to the laundry and went inside the dryer and tried to take out sheets? Let's say you take out sheets from a dryer and you take it out from the dryer and you try and pull a blanket away from a sheet and you go, ah! Have you ever gotten an electric shock? I want you to imagine that. What happens with an electric shock? In the electric shock, or static cling, if you will, happens between the fabrics. The static cling causes one particular piece of fabric to cling to another piece of fabric, and that electricity between the two pieces prevents the two pieces from separating unless they're pulled apart. That type of phenomenon is based from electricity. Now, the difference between, let me get this out for you, the difference between a cloth mask and an N95 mask is electricity. Now, let me break this down for us even more. Now, before the pandemic, we saw just only a couple people wearing face masks. We saw construction workers wearing face masks because they would sand down and polish down wood and deal with fiberglass, and they needed to make sure they had N95 masks or higher filtration masks on to prevent particles from going into their air passages and getting lodged in their lungs. Fiberglass, for example, people dealing with construction have to make sure and put the proper filtering system on to ensure no contaminants get lodged into the lungs. Now, in the other case where we saw people wearing masks was doctors' offices. We saw you saw the surgical mask, the mask that the surgeons put on, and we always see that on TV when doctors are supposed to be giving surgeries. They put the mask on. Most people haven't gone through surgery, so they wouldn't know that people have masks on in the surgery room unless they are watching TV. In any case, we were used to seeing people wearing masks in those situations, but when people were asked to wear masks in general, people were not aware of the function of the mask and how it works. So I'm going to show you how a facial mask works So you'll be knowledgeable on why health officials like the World Health Organization and the CDC and other health organizations suggest wearing an N95 mask and proper filtration for your nose and mouth. Okay. Fabric. Fabric is really interesting. It's fabric is a type of weave. Imagine there's different weaves of the fabric and they go together like this. Well, when fabric is weaved, there's naturally holes in the fabric. It's very small microscopic holes, but fabric has holes to it. It's because of how the fabric is woven. Well, if someone were to place just regular fabric on their face, if they were to place regular fabric on their face, this fabric would have some sort of protection. It would protect out particles. Now, there's three types of particles to be concerned about, and I'm just going to break it down in a way that makes a lot of sense. There's big particles, there's medium-sized particles, and there's very small, minute-sized particles. Each one of these particles have to be filtrated from some sort of facial mask to keep it from going inside the nasal passages, because if there's any type of contaminants that goes inside of the lungs or nasal passages, for example, if there's a virus, which is a very small particle, if it goes inside any one of the nasal passages, it can stick to, depending on the virus, depending on the respiratory virus, and doctors and medical researchers are the ones that can describe this much better than I can. But in any case, just in short, any type of virus, it can get stuck to any one of the membranes and tissues in the mucous system, and it can replicate. So the whole goal is to keep it from sticking to your system and making sure there's not an overload of virus particles to stick to the system, so it can be flushed out of the body by the immune system. So this fabric, it's helpful with doing two things. It's great with keeping out the large particles. Now, the large particles, what are the examples of large particles? Well, let me just say this. The large particles will bounce off and actually stick on the exterior of a mask. And this is actually a clean mask. I am not by any way ever going to touch a dirty mask on the outside. That's like contamination. So this is a clean mask. But what happens is that the larger particles get blocked by one of the pieces, by the fabric itself. Really small, minute particles travel in a chaotic way, and it's called Brownian motion in mathematics. These smaller particles travel in a chaotic way, so although it may go inside of one of the fabric pieces, one of the holes of the woven fabric, if there's several layers of fabric, the several layers of fabric will then have an extra boundary layer of this small particle. And since this small particle travels chaotically, it's more than likely going to bounce off one of the layers of the fabric and then get caught to it. Now, remember that type of analogy I presented earlier with the sheets that stick together? Well, anytime there's fabric that runs together and there's any type of movement, and there's called an electrostatic charge. Now, we naturally move around. When we move around, the fabric moves around. If there's layers of fabric that moves around, there's naturally an electrostatic, I should say, electrostatic charge that when a smaller chaotic particle goes through this fabric piece, it then gets caught onto one of the layers of the fabric, and then it keeps it from going into the nasal passage. So that's what's helpful. Now, the biggest concern is when there's particles, virus particles, that attach to other particles in the air, and that air then circulates and then enters the body. That's what the scientists are concerned about. Now, let me break this down for us a little bit more. Viruses do not, actually, I should say this. Viruses, what they do is that they attach to other particles that are in the air. And as these particles go through the air in the natural current of the airflow, it then can be inhaled by a human. And that's the part that people are concerned about. That's the part they don't want. Now, why does an N95 mask work in the third case with the particles that are medium sized that attaches to other particles in the air and that travels in the airflow? All right, I have over here sieves. Now, these sieves, as you can see, they have holes in them. Now imagine a piece of fabric having holes in it. But if you layer the pieces of fabric together, let me layer it like this. If you layer the pieces of fabric together, the holes are all not aligned. They're in different places, right? So normally with the fabric mask, you have different fabric pieces that are layered together. The holes are not aligned, and therefore something can get blocked by if it's a large particle, it gets blocked by the exterior. If it's a very, very small particle, it bounces around and sticks to one of the pieces of fabric that is in here. And then if it's traveling in the air, that's the part that gets tricky. If it's traveling in the air, the electricity is what's responsible for stopping the particle from going into your nose and to your mouth. Now let's describe this. An N95 mask is, or similar to N95 mask. There's different versions out there. N95 is a special certification for a mask, but there's similar mask, and this is how it's built. An N95 mask has pieces of fabric and plastic intertwined in layers, just like the regular fabric has. But the N95 fabric pieces are charged with electricity. Yeah, you heard me correctly. There's like I'm not quite even sure how you say it. You create an electrical charge in here. So it's like a static cling inside the layers of the mask. So now imagine the layers of the mask that look like this. There's still these holes, but the more layers you have, the more areas that things can get attached to. But if it's the particle traveling in the air, that's the energy force that's actually pushing it through the layers of the mask. So if the mask has an electrical charge, meaning if there is an electric charge placed on the layers of the fabric of an N95 mask. Now imagine this. Imagine if this was charged with electricity. If something were to try and get through one area of the sieve, it would get to the second piece. But what more than likely would happen is if this had this same type of static cling, if you will, that we saw earlier in this podcast, if there is a charge to this particular set of layers to a mask, that particle that is traveling in the air with the airflow that has the virus attached to it will get stuck to an interior part of this mask, so it doesn't go in your nose and mouth. Can you believe that? So if you have one mask on, it's very helpful. If you have two masks on, it is even more helpful. If you have 3 masks on, then you are presenting an electric maze that a particle has to get through in order for it to get to you. So the goal is wearing a particular filtration system to block out the big particles, the medium particles, and the smallest particles, so you have maximum protection. Now, what is helpful for you? Now, if you have a mask, and this is a cloth mask, it's really important that you cover your chin and make sure it's fitting your face well. Now, this is a mask that I have that's cloth. You want to make sure that you have ample room to put your ears in it. And then when you touch the mask, only touch it at the ear hoops. You want to avoid touching the exterior of the mask, because the exterior of the mask has particles that more than likely are stuck to it from that natural airflow which we were talking about before. You also want to make sure it's fitting, meaning there's no gaps. The best way I can describe it is if you wear the wrong underwear, if you don't wear the right underwear, you won't be fitting correctly. It's the same way with the mask. You want to give yourself as much support as possible, and you want to make sure it fits snug, not too tight, not too loose, because if it's loose, it will create air gaps, and these air pockets trap in air in which you don't want. Now, so if you remember what we talk about in this particular podcast, which is the main difference of the cloth mask and an N95 mask is electricity, then you'll understand the power of mask. Now, I wear a mask, and there's a lot of people that do, and it's very helpful. It is, in some places, it's a mandate, in some places, it's a preference. And in any case, my goal is to tell you the science of how a mask works, so you can make the decision to protect yourself in all situations. I am Olympia LePoint. I hope you enjoyed this particular talk. And just remember, that static clean that keeps things stuck together is what's going to keep you alive. I'm Olympia LePoint. For more podcasts, check out answersunleashed.com/podcast. Find me on Facebook, Instagram, and LinkedIn under my name, Olympia LePoint, and find us on YouTube under Answers Unleashed. Call us at 888-88-ANSWERS. And until next time, I'm Olympia LePoint, and stay safe.